Okay, good morning students. In this session we are going to study the principles of measurements as well as errors in measurements in the module 3. For this module or for this chapter we are going to need the textbook that is written by the Ece 18Ec36. The title is Electronic Instrumentation, that is published by McGraw-Hill in 3rd edition. Okay, we are supposed to refer and we have to study the material from this textbook, and I have taken the material from this textbook. So in this chapter, in this module, in this session 4, we are going to study about the static characteristics of a measurement device as well as errors in the measurements and types of static errors that are present in the measurement devices. Okay, next, an instrument. What is instrumentation? What is instrumentation? It's an art and science of measurement and control of process variables within the production of a manufacturing area. Okay, once again I am going to repeat this. Instrumentation. It is an art and science of measurement of control of process of variables within a production of manufacturing area, and principle and operation of measuring instruments used in this design and configuration are all automated systems. So, what is measurement? The act of or result of quantity comparison between the predefined standards and unknown quantity to be measured. So, in the measurement, when a device, we want to measure a quantity which we have theoretically calculated, but we don't know what is the measured value. The unknown quantity what we want to be measured, but we have predefined standards, a predefined value, but we don't know what is the actual quantity of the particular measure. That is what we are going to call as measurement. What is measurement instrument? A device for determining a value or a magnitude of a quantity or a variable. So it can be variable, or it can be magnitude of a variable, magnitude of a quantity, it can be anything. That's what we call as measuring instrument. So electronic instrument, it's an instrument based on electronic or electrical physics principle for its measurement functions. The measurement of an electronic and electrical quantity or variable is termed as electronic measurement. Example, the voltage, current, as well as different types of the devices. We are going to resistors and electronic measurement devices are there. The electronic measurement components are there. We are going to measure those quantities. That is known as what we call as electronic instrument. And what is measure and? It is a physical, chemical, electrical quantity, property, process, variables or condition to be measured is known as measure and. What we are going to measure? It can be physical, it can be chemical, it can be electrical quantity, or it is a property of electrical quantity, or a process, or a variable, or a condition to be measured. That is what we want to call as measure and. Next, measurement of any quantity plays important role not only in science but also in all branches of engineering, medicine, and almost all human day activities. Okay. Next, we are going to study what is measurement. The measurement of any given parameter or quantity is the act or result of quantity comparison between the predefined standard and unknown quantities to be measured. That's what we are going to call as measurement. Next, we are going to study the static characteristics. So, static is a fixed characteristics of a device or a device. So, it is a fixed quantity. It cannot change with respect to time. That's what is known as static characteristics. There are different static characteristics of the device or a measurement devices that are there. They are fixed. They are not vary with the time. So those static characteristics are defined as instrument which measures the quantity which do not vary with time, as well as the various static characteristics are accuracy, precision, resolution, error, sensitivity, threshold, zero drift, stability, linearity. But we are going to study the some of the characteristics of the static characteristics of the device. First, Accuracy. It is a degree of closeness with which the instrumentation or instrument reading approaches to a true value of the component. The accuracy in which the device reads the reading, that is known as accuracy. If I give you an example is, if I have a resistance of 1 kilo ohms, if I measure with the using of what we have is digital the digital resistance meter, digital ammeter, where we have the resistance meter over there. If I keep that 1 kilo ohm resistor in the device, if it shows so near 999, so it's nearly equal to the accuracy. So it should show 1 kilo ohm only, whatever maybe is. So plus or minus 5 deviation will be there, but accurately in which it decides is known as accuracy. Next, precision. It is a measure of consistency or repeatability of the measurement. If n number of times I measure the same value, it should show the same value. It should not vary with the time. It's a consistency in which the device measures the precise value. Next, resolution. It is the smallest increment of quantity being measured which can be detected with certainty by an instrument, or smallest change in the measured value in which the device responds. See, resolution is nothing but the plus or minus variation will be there in whatever maybe the devices are there. So due to temperature change, the quality can be, the value can change with respect to time. So that's what known as resolution. Next one is significant figures. These conveys the actual information about the magnitude. At the same time, it also contributes to the resolution. So it's a combination of resolution as well as the magnitude of the value. So n number of times we are going to add those values. We are going to take the magnitude of that particular value, and we are going to use the resolution of the particular device. Next one, error. So the most important static characteristic of the instrument is its accuracy, which is generally expressed in terms of error called as static error. So it is a fixed error. So there were small errors may be changed in the error. That is given by the equation. We know this, E is equal to AM minus AA, where E represent error and AM represent the measured value and AA is actual value. So actual value what we have theoretically calculated, and AM is the quantity to be measured by the device. That is known as static error. The static error is defined as the difference between the true value of the variable and the value indicated by the instrument. That is what we know as static error. The static error, once again I am going to repeat this, the static error is defined as the difference between the true value of the variable and the true value indicated by the instrument is known as the static error, and it is the equation is given by E is equal to AM minus AA, where AM is the measured value and AA is the actual value of the particular measured value. Next, we are going to study the gross errors. The gross error is mainly occurred due to the careless or lack of experience of human being. If the person using the device, he doesn't know how to use the device to calculate or measure the value, he doesn't know how to use the particular device and how to read the value, so that is what we call as the gross errors. Next one, systematic errors. The systematic errors are mainly resulting due to the shortcomings of the instrument and the characteristics of material used in the instrument. Okay, systematic error is what we call as the material that has been used in the measurement device. Okay, or an instrument. So in the instrument we have, in the instrument is the whatever measurement instrument is made up of the electronic devices. They change their characteristics with respect to time as well as with respect to temperature due to the change in their heat. So some of the normal characteristics may vary with respect to time. Due to this change of radiation, the output reading may also change with the time. That's why it is known as systematic error. These are error caused by the instrument due to change in the heat or change in the characteristics of the material that are used in the instrument. That is what we call as the systematic error. Okay. Next, there are three different types of systematic errors are there. One is instrumental error, second one is environmental error, and third one is observational error. So instrumentation error occurs due to the instrument which is present in the instrument, which can change the value with respect to time. The environmental error are called due to the magnetic flux of the nearby electromagnetic device, or a transformer or AC is kept between the device. Due to this, the forces electromagnetic radiation on the nearby device, they may change the normal operation of the device. This is what we call as environmental errors, as well as temperature, nearby surrounding temperature. If the temperature is high, the device or instrument may change, its normal functioning change may vary. And observation error, these are errors caused due to the human errors. Observation error caused by the human. There are different what we as conclusion errors or complex errors or conclusion errors. If the person sees the value in a different angle, it shows the different readings in the analog meter. These are the error caused by the observation error caused by the human, most of the time by the human errors, not by the devices. That is what we call as observation error. And next one is random error. These are error that remains after the gross and systematic error. These random errors will be there even after the gross error as well as systematic errors. When the error is specified in terms of absolute quantity and not as a percentage, then it is called as absolute error. Okay. Next, thus the voltage is 10 plus or minus 0.5% is indicated by plus or minus 5 is an absolute error. So it can be shown as 10.5 or minus 9.5 to the range is from 9.5 volts to 10.5 volts. Next, so error can be expressed either in the absolute or percentage of error. Absolute error can be defined as difference between the expected value of the variable and measured value of the variable, and the equation is given by E is equal to y of n minus x of n. This equation, and this is the material is taken from the textbook Ece 18Ec36, the electronic instrumentation, where E is the absolute error and y of n is called as expected value and x of n is called as measured value. Therefore, the percentage error of this equation is given by absolute value divided by the expected value into 100%. That is about E is equal to E divided by y of n into 100. Therefore, the percentage error is given by y of n minus x of n divided by y of n into percentage error. This is the percentage of error. It is more frequently expressed as accuracy rather than error. Then absolute error equation is given by A is equal to 1 minus the magnitude of y of n minus x of n divided by y of n, where A is called as relative accuracy or accuracy. The accuracy is expressed in terms of percentage of accuracy. The percentage of accuracy is given by A is equal to small a is given by 100% divided by percentage error. That is given by A is equal to A into 100%, where A is called as percentage accuracy. Next, and we are going to study in the measurement analysis, we are going to study statistical analysis. In statistical analysis is analysis used for helps in analytical derivation of the uncertainty of the final test. So when we have uncertainty, we are going for a n number of values. We are going to take the readings for n number of times and we are going to add those. We are going to take the average of those and divide by n number of times. It's called as statistical analysis. We have the vector values will be there and we are going to calculate this, and that is known as statistical analysis. In statistical analysis, we are going to study arithmetic mean. When the quantity is measured many times and all the measurements are not same as them, this method is known as arithmetic, and the equation is given by x bar is given by x1 plus x2 to the power x to the power of n divided by n. N is the n number of readings. So x bar is arithmetic mean and xn is nth reading is taken by a is nothing but these are the different 1 to if xn is 100 and then x1 starts from 1 to 100 and the n will be 100. So it is known as arithmetic mean. Next one, deviation from the mean. This deviation is given by the what we have this reading from the equation d1 is equal to x1 minus x bar, d2 is equal to x2 bar is the n number of deviation. So expected value, the measured value. So if there is a changes, x bar is arithmetic mean is fine. Then we are going to difference with the first value. We are going to differentiate this with the actual value. Next one, average deviation is the indication of the precision of the instrument used in the measurement. The average deviation is defined as the sum of absolute values of the deviation divided by the number of readings. The average deviation may be expressed as d average is given by the magnitude of d1, d2, d3 what we have taken the deviation, these are deviation values. We are going to do the average of those values and we are going to divide it by n number of times. This is what we want to work out as average deviation. Next, standard deviation. Standard deviation is the square root of sum of all deviations squared and divided by the number of readings. So we are going to square root of the deviation values and divided by the number of readings. So that is given by the is the equation. And the square of the standard deviation is called as variance. It is given by sigma square is given by d1 square plus d2 square d3 square, and dn square by n is called as the standard deviation in terms of variance. Next one, dynamic characteristics of instruments are given by there are a set of criteria defined in the instrument which are changes rapidly with respect to time, which are called dynamic characteristics. Previously what we studied is static characteristics which cannot change with respect to time. But in dynamic characteristics, they are going to change their characteristics with respect to time. The first one is speed of response. So they say a sudden change in temperature should be measured by the sensor. So the sensor should respond to the sudden change in the temperature such that it should calculate sudden change of temperature from 30 degrees centigrade to the 31 degrees. That's a speed in which the device measures the value is called as speed of response. Next one is lag. There will be some delay because the device may be far away and the reading measurement device is some other location. So there will be some time. So there is a lag of time. That is what we call as lag. Next, fidelity. Fidelity is a different characteristics. So it can be fiddled by the different device characteristics. This is called as fidelity. Next, dynamic error. These are the errors caused due to there are certain changes in the device, instrumental clusters, human errors. The combination of human as well as instrument errors is called as the dynamic errors. The measurement of error combination, when quantity is calculated from measurement, is made on two or more. The instrument is known as dynamic error. Okay, thank you.